We going? Yeah. Okay. So, I heard some discussion. Where does sine start? 0. Good. So we start at 0, we hit a maximum, then another 0, a minimum, and then another 0. Sometimes it's easier to put the dots first. Make sure your graph actually looks right. And we have an amplitude of 1, right? What are our 2 marks here? But we hit a maximum. Our halves, pi is 0, 3 pi halves, and 2 pi. Okay, that should be pretty common knowledge. Okay, number 2, cosine starts differently. Starts at a maximum. What if it switch 0? 5 halves. What if it hits a minimum? Pi. What if it hits 0? 3 pi halves. What if it hits maximum again? 2 pi. So look at this, it should be curved. Like so. That's one period of time with amplitude 1 again. Okay, so remember what the derivative of sine was. Cosine, good job. The derivative of sine, so f prime of x is cosine of x. And we just got that one, so just copy it back down. We have, I have to make sure the derivative of x is pi, 3 pi halves, and 2 pi. So it's just the cosine graph. Like so. You're going a little high on that one. Okay. What's the derivative of cosine? Good. The derivative of the cos changes signs, right? So derivative of cosine, cosecant, cotangent, all change signs. So the negative side of x. So after the flip, so we can start at 0 still, but we get a minimum first, and then at 3 pi halves we hit the maximum. Again, same amplitude. Make sure all of your axes are labeled. Are we good with that? Okay, so we're going to just go through the other trig function derivatives. Using the rule we had last week. So, tangents. Remember on your trig identity page, we write tangent in a different form using sines and cosines. Sine over cosine. When I go to any tan and tan, I have to put a in the place of tangent screen and I still burn, so it doesn't really work. So this is division. We know the derivative of sine, right? We know the derivative of cosine. So we can apply the quotient rule to find f prime of x. F prime of x, how does that same go for d dx of f of x over g of x? D high minus pi d high over or you can say rho d high minus pi d low over rho low squared. Okay, I have some other stuff in my head, so I have to do the high ho's. High ho, right? But high ho just means low. High means numerator. Okay, so for the quotient rule, ho, or low, means we take the denominator as is. Cosine of x. High, d high. What does the d tell you to do with the high? Derivative of the high. What's the derivative of sine? Cosine. So we're going to times by cosine. So now we have cosine x, cosine x. Please make sure you write the x. Don't skip that part. Minus high. You know what the high portion? Sine x. Good. Time d low or d low. The derivative of the low. So the derivative of cosine is negative sign. So make sure you don't like you're subtracting. Make sure it's actually times it. Over ho-ho, or the rho squared, which is cosine squared. Now cosine squared, you don't put a square on the x, Otherwise it would be cosine x squared. We want the cosine portion to be squared, so it's cosine squared x. Okay, so let's simplify and see what we did. And that equals, what's cosine times cosine? That would be cosine cross cosine. So cosine squared x. What's a negative sine x times a negative sine x? Plus sine squared x all over cosine squared x. The numerator is the trig identity that we use all the time. Cosine squared x plus sine squared x. So you want to know what that equals? No, because you won't be getting, we'll just be getting back to that. We don't, I'm trying to get to something else. This is the trig identity we need to know. If you don't know this, you can pull up the trig identity page. I think call it sine squared x plus cosine squared x. It equals 1. Cosine squared x plus sine squared x equals 1. It's a very common one, so you need to have that memorized. 1 over cosine squared x. This looks pretty dang close to reciprocal identity. Plus 1 over regular cosine x. It's reciprocal of the cosine function. Does it see that? Yeah, because it does sine, cosine, tangent, and these alternate. Cosecant, secant, cotangent, so CSC alternate. So yeah, cosine and secant. So 1 over cosecant squared x is just the function secant squared of x. That's the, I remember. That's the derivative of tangent. Okay, so we're going to make a listing. The derivative of, if a function is sine of x, the derivative is cosine of x. If our function is cosine, what's the derivative? Negative sine of x. We just have a new one. If our function is tangent, what's the derivative? Positive secant squared of x. Okay? Now we want to do something similar and that would be a lot smaller. Define cotangent. Look at your trig identity page. It's easiest to work with sines and cosines. You define cotangent in terms of sines and cosines. You'll have this trig identity page. There might not be extras up there anymore. I think I leave out all the root stuff. It's cream colored. You should have this. This is like your trigonometry Bible. Something to hold on to ever and ever. Cotangent in terms of sines and cosines. Yeah, cotangent x equals what? So the reverse of tangent, cosine x over sine x, which makes sense because they're reciprocal, aren't they? So just flip the fraction. So we do the same thing, holding high minus hiding low over ho. So f prime of x. Emma, can you get the numerator for me? Holding high minus hiding low. So the derivative of cosine is negative sine of x. Good. We're okay with that. Ho, you have it, so the one substitute the derivative of minus high in ho over, so now I'm going to go to the denominator. Good, she was that right. Sine squared x. The square root of sine, non x. Okay, so simplifying. Sine x is negative sine x. Now let's put that. Good, negative sine squared x. Okay, correct about negative cosine x times cosine x. Negative cosine squared x all over sine squared x. And the numerator 1. Ooh, it's negative 1. That identity is positive, right? Positive cosine squared plus sine sine squared equals 1. So if I factor out, they both have a negative sign. If I factor out a negative 1, and we see what the following is. Positive sine squared x plus cosine squared x all over sine squared x. So the numerator is what? Negative 1 over sine squared x. That was like reciprocal. If you ever see a 1 in the numerator, it's always going to be reciprocal of any. So what do we get? Cosecant is 1 over sine. So it's negative cosecant squared because of the square. We have 2 of them. So you get negative cosecant squared of x. So cotangent, without that function, the derivative is negative cosecant squared of x. We can use the parentheses that really don't need those parentheses. Okay. One more. 1, 2, 3, 4. Okay, I'm missing. Oh, because the other ones are. Okay. Number 5, cosecant. We need cosecant in terms of sines and cosines. We need a trig page. Do you see cosecant in terms of sines and cosines? Love it. Now over sine, the reciprocal identity is in terms of sine. Okay, so cosecant equals 1 over sine. We're going to do the quotient rule for f prime of x. Pi minus hi ho over ho ho. Okay? I want you to try it with, you can work with the numerator. I want you to go through that same process. Ho would be pi, the denominator times the derivative of the numerator, minus hi ho over ho ho. What's your answer?
Not my answer.
We need x in there, because this looks like sine of 0. You have an x? Yeah. Okay, who has the numerator? Christine, you have the numerator? Holding high with a roll. Good. And you do have another x. Don't drop the x, otherwise it's sine of 0, which is something else. Okay, this cancels out. Oh, what's the denominator? Sine squared x. So f prime of x is negative cosine x over sine squared of x. Which is, can I break this up into 1 over sine x times negative cosine x over sine x? Is that legal to have 2 sides because you know how to break them up? Now we know this first guy is a reciprocal identity. cosecant, you can't see it anymore, times, what's the next one? Negative cosine over sine, negative cotangent of x. So I'm going to bring negative in front. I have negative cosecant x times cotangent x. This one's not as pretty, but that is the derivative of cosecant. It didn't have cosecant in it. Okay, so cosecant of x ends up being negative cosecant x times cotangent of x. So if you ever can't remember that one, you can derive it using the question rule. Yeah, so I'll tell you the last one, but it's the same process using the question rule. The last one is we're missing cotangent. Not we're missing, these are the wrong ones. Secant, you're right. Secant. Again, using the same process, secant of x is not so pretty. The derivative is secant x tangent x. Okay, I'm also going to show you a shortcut derivatives. It's called, let me get it, I haven't used. Okay, I'm going to write this down. Okay, so how much in the last two? If you're taking the derivative of secant, it becomes secant tangent. If you're taking the derivative of tangent, so in the end, the derivative of tangent is secant squared. Oh! Okay, and I have another one. I just realized I short that. Secant tangent. Oh, I wrote this last year. And that's the same for the other two, except for in two to sine, so we're taking derivative of cos. So, secant reciprocal is what? Cotangent? I'm just writing it out for myself. Cosine. It's not, I wrote this last year, because I just do C, that makes no sense. I forgot how I wrote it last year. But there it was shortcut for those two. I'll put it back to you on the other two. So we have secant shortcut is secant tangent, that's this one. And tangent shortcut is secant squared. That's that one. I don't have an extra cut for those two, but I forgot what it is off the top of my head. Okay, Cody, I can help you. Hi. If you're not interrupting, because we're on a crunch schedule. Okay, so let's do the next slide. Alright, this is another rule we learned question rule. How much time and how you all over on home? What was the product rule? First, last to first. And say we have one more. Coefficient rule. What is the coefficient? It's a constant where multiplying to like a variable or a function. That's a pencil hand. Okay, so if you have a constant times some function like g of theta, theta can be a placeholder for x. Sometimes there are functions in terms of theta, sometimes it's in terms of x. So you have to be comfortable with both. Theta just means the x-axis is now the theta axis. Okay, so we're taking, we have a constant times a function, we take the derivative, you just pop the constant out, you don't actually have to take the derivative of the constant. So we're going to take the dv theta, notice it's theta not x, dv theta of c of g of theta. Since I'm in terms of theta, I can't say ddx. I have the variables agree. Does that make sense, guys? If this was g of x, that would be ddx. If this was g of theta, we have to have dv theta. That to take the derivative, d theta, and then take the derivative of it, all that happens is I pop the c out in front, and I take the derivative of the function with respect to whatever variable or x symbol is given. So the constant can be popped out in front and that multiplies at the end. Yeah. So the iteration problem is, yeah. So for instance, you know, write this down, but if I was to take the derivative of 2x squared, I can just pop the 2 out and take the derivative of x squared. What is the derivative of x squared? So I have a 2 times 2x now, which is 4x, which is the same thing as equals 2 multiplying, right? 4x the first power. So it works for both. Okay, so number 6, our constant, our coefficient is 3, right? So we're going to take the derivative of y. We can pop out, we're going to put it here, dx on both sides. Then if I don't want that, I have to do it to the other side. So I have d dx of y equals, and we pop the 3 out in front, 3 times d dx of sine of x. Because we know the derivative of sine of x. What's the d dx of y? That's the derivative of y. That's what d dx means, the derivative of y prime. Of 3 times the derivative of sine. Cosine. So the constant doesn't really do anything. It just tags along. I shouldn't say constant, I should say coefficient. The coefficient just tags along as a multiplier. Not always, but that problem I just did. I took the derivative, it ends up being a 4. But it multiplies to whatever ends up being in front. Okay, so that's one. Number 7. If I do d dx times I need x, because my function doesn't have a theta, it has a cosecant x. I'm going to take the derivative of both sides. So I have to do both sides. d dx of y equals 3, pop the coefficient in front, of d dx of cosecant x. Now, what are we going to have on the left side? Good. What about the right side? Good. That's the wrong one. Okay. Now the next one has the product rule. See how we have two functions being multiplied? We have the quotient rule times the quadratic polynomial times the trig function. That's the quotient rule. What's the quotient rule again? No, I'm saying wrong one. Sorry, so I send it. Okay. Product rule, please. Thank you. First, last, plus, last, do first. Okay? First, it doesn't really matter because we can multiply in any order, right? Because you're using the first one right in. I'll go first. Let's go to the second. So, dx both sides. So I get y prime equals first. What's first? X squared dy is the derivative of the last part. Cosine x plus last is the last part. Sine x times, make sure you notate that it's timesing because it's going to be part of the sine function. Sine x times dy is the derivative of the first, d first, 2x. Now if I keep that 2x there because it looks like it's part of the sine function, I would pop it in front, so it looks like this. Okay? And that's a derivative. Y prime or dy dx is another way to write y prime. Any questions? Okay, let's do a tangent line. Number 10, let's go to number 9. Given this function of x equals x cosecant x. So we have a product rule going on. You see the product? So linear x times a trig cosecant x. If you have to be able to identify those right away. Find the tangent line. Find tangent. What does that tell you have to do? Derivative. But in order to write the tangent line, that's the equation. What do you need for a tangent line? Point. And slope. What does the derivative give you? Only the slope. Not half the point. Right there. You can find the y value by putting it in. So we need to the derivative. But that only gives us the slope. So don't just stop after the derivative. So I'm going to, oops. I'm not there yet. I'm going to do f prime of x equals, this is the product rule. Brendan, what is the product rule saying? Thank you. First class, there's an operation in the middle. First class plus last to first. Okay, Kennedy, can you tell me what the right to the product rule for first class plus last to first? First. X d last. That's one. Negative. And then negative cosecant. Yeah. Do they write it down? Okay, which one are we doing right now? Cosecant. Negative cosecant. So, cosecant derivative also has cosecant in it. Secant derivative has secant in it. So, keep that in mind. So, negative cosecant x cotangent x. Cotangent x. Okay, that's first d last. Plus last. Cosecant d first. Times 1. That's not x times 1 is cosecant x times 1. Okay, so we have f prime of x equals, I would just keep that x out for a second. And cosecant, I don't know why I'm rewriting this, because times 1 doesn't do anything. Okay, two notice that they both have a cosecant. You see that? So they probably tried backing that out. Cosecant x. I back it out of here. I get up with a negative x cotangent x. This part and the negative in that part. Well, how much? 1. Interesting. Okay. What else could we do? We're finding the tangent line. We're finding the slope. Okay, come on. Let's start putting it in now. Pi halves. So cosecant of pi halves minus pi halves cotangent of pi halves plus 1. Okay. So little intense. Cosecant. So what you can think of in terms of sine. What's cosecant in terms of sine? 1 over sine. So it would be 1 over sine of pi halves, because we know what sine of pi halves is. How can we rewrite cotangent of pi halves into something that we actually know? Cosine over sine. So we do have a negative pi halves in front times cosine pi halves over sine 1. Okay, sine by half, that's another graph. I just always give it a little squiggle, so I remember the sine graph have visual. Where is pi halves? If this was sine. Yeah, the maximum, so that's 1. So we have 1 divided by 1, which is just 1, minus pi halves times the negative pi halves. However, let's cosine the pi halves. So cosine, just give myself a quick graph. So I remember what cosine looks like. What's cosine of pi halves? 0. It's right there. 0 over the sine of pi halves again. We just did that one. 1 plus 1. So 0 divided by 1, 0 times pi divided by half, that's all gone. So I have 1 times the positive 1, which is just the slope of the tangent line equals 1. That's not the answer. We can do all these long problems. We want an equation. So we have the slope, we have an x value. What are we missing? The y value. The point. How do we get the y value? Plug it in into the original position function so we have pi halves equals pi halves cosecant pi halves. And we do the same trick. What's the reciprocal of cosecant? 1 over 5. You have to start getting these ingrained in your head. If you have sugar reciprocals, start memorizing them. Oh, pi halves, we've done that. We just did that twice. Yeah, so pi halves times 1 is just pi halves. So our point is pi halves, pi halves. Okay, and then what are our equations we need for point is pi halves, pi halves? Y minus y1 equals m times x minus x1. So, first, y1 is what we plug into. So, y minus, we can write that, but we don't really have to. It's okay if we do, okay? There we go. You can stop. You don't have to move stuff around. Just stop instead of making mistakes. Okay? Does that make sense? Are you kind of okay on the quotient rule, the particles from last week? Okay? And velocity, acceleration when the particle's going forward versus when it's going backward. And we're just going to see that change. If you don't know when the particle's moving forward on a graph, which is when it's moving backwards on a graph, you might want to take a picture of these. Okay, so when a particle changes direction from velocity of 0, and changes time, or changes signs. And going forward, you can see that the particle is going up, when the velocity is greater than 0. So it's above the x-axis. It's going down or going backwards when the velocity is less than 0, and the velocity function is below the x-axis. Speed is not just velocity. Speed is the absolute value of velocity. Those who take physics probably have a more familiar, more comfortable with these. So if I'm taking physics, speed is the absolute value of velocity. Fastest when v is further from the x-axis. Could that be below the x-axis? Yeah, because speed is absolute value. So it's the fastest when the velocity is furthest from the x-axis. So the point at which you're furthest from the x-axis, whether it's above or below. If speed is, I don't like to say speed up, but I would say speed. So I talked about this in the video. I remember PE, they're the same vowel, right? So velocity and acceleration have to be the same sign. Both positive, but both negative if it's speed. And slowly, when they have different signs. And if the constant speed, the acceleration is 0, or the velocities, the slope of v of t is what? Well, the acceleration is 0, the initial say slope. If the acceleration equals 0, what's happening of T. Any maximum means? Am I right? An acceleration of 0, that happens when the velocity is hit a maximum in. I would take a picture of this if you don't know the names of moving forward or backward, the names of speeding. And our final next time, so you have chapter 1, chapter 2, and chapter 3 reviews. I would go back through all of those, especially chapter 1 and chapter 2, use the same reviews. So on campus, if you want to just print a new one, there's probably lectures over there with others. So you have a blank copy to practice off of with all your pictures. Oh, and if you have any of the extra credit, go ahead and put your photo or you can give it to me tomorrow. That won't be it. Oh, I forgot. Studying bonus songs coming up in November. Pay attention to those and you want to start. And BYU gave us 3 tickets to split between this class and AP Stats, where they're having a banquet on November 11th. November 11th, if you're interested in mathematics, we think it's mathematics education program at BYU. We have 3 tickets. It's a banquet, a dinner. No, it's November 5th, Thursday at 6:30. If you're interested in mathematics education program at BYU. Free dinner. Student scholars for all student scholars, including math, comes up in November. I think it's November 20th. I think, I'm just going to call soon, but I can remember that we'll have like packets to fill out if you're interested in applying. I think it's November 20th. Let me check. I wrote it down at my meeting today. Oh, and people did this. I really created those. It's in my computer. November 20th is when the applications for Student Scholar are due. Student Scholar applications, so you'll be like the math Student Scholar, or the music Student Scholar, or whatever. It's due like, November 20th. Is anyone interested? BYU Math Education Program. I'm not sure. I'm a little confused what this actually was. We thought originally it was just like. It's a high school recognition banquet for higher level mathematics educators and exceptional students. And then the brochure says math education program. That means as masters. So I don't really know what it is. All right. Thank you all. It's a graduate program. Why are we doing this to us? It's a graduate program. We don't have a bachelor's degree yet. Would you please make them available to any of the teachers that will be interested in pursuing a master's degree in math education? We already have a master's degree, so I think that was miscommunication. Yeah, well, I was thinking this next time I might move to Europe. I would move to London for the summer. I can move. Got something going. Went to Chicago for the whole summer, and I just lived there. I had an apartment, lived in the city, became a couple. It was like the best summer of my life. And this summer, I just stayed home and stuff over there. I was so bored. So bored. So, yeah, especially with the news feed, there's so much to discover. I'm not. This is my first trip over to Europe, and now I'm like, oh, I have to go back. Mm-hmm.
London is a very clean city for being a really major city. Like,
Yeah.
the streets are very nice and clean. They, even said that they will give, what people will do is they'll donate like suits that they have, and they will give them and serve poor people will have suits.
Mm-hmm.
Even if you saw someone and they're on the side of the street, they would look for them.
Yeah, that's what my friend said. One of the homeless people